lecture for 4.2 and 4.3. Also, you can get more out of it too if you watch the notes. I did the whole notes for the chapter yesterday, and I posted those also. So, the electromagnetic spectrum beyond visible light. Now, what we're talking about here is this area and this area. This is what we can see of the spectrum. This is what humans can see, the visible light, and then what's on either side of it. Again, watch the notes. Watch the notes. They'll help you a lot. Here's wavelengths matched up with the different astronomical sources and what kind of radiation, like radio waves, shortwave radio waves, TV waves, etc. All right. And as you go down, it's going to explain here's one, William Herschel, Sir William Herschel, and how he discovered infrared radiation, ultraviolet radiation, J. Ritter. It'll talk about him in here as you're reading it and how he discovered that. Radio waves, James Maxwell and his radio waves. For some reason, my mouse is not working. James Maxwell and Heinrich Hertz, and how they discovered and created radio waves. And then the X waves, X-ray and gamma waves, Wilhelm Röntgen, 1895. And the energy carried by these waves, by the photons and the waves. Notice here too, and I go more into detail in the notes, how we have, this is visible spectrum. This is the same, we are all looking at the same object here, but in the visible spectrum, if you were to look up, this is what you would see with your naked eye. But if you use infrared or radio telescopes, this is what we're going to see. If we're going to look through ultraviolet or X-ray telescopes, we're going to see something different. So each wavelength gives us a different picture. Each wavelength is going to give us a different picture. The next section, 4.3, the nature of matter and heat. All right. And this goes in how it starts with the atom, protons, neutrons, and then the electrons cruising around the outside. Goes with the temperature scale of Kelvin. And Kelvin was very popular, or he studied steam mostly because at the time, all machines and trains, everything ran on steam. So he came up with a new temperature scale. Temperature and radiation. Now it starts to link these different colors, different wavelengths have different temperatures because they have more or less kinetic energy, right? And remember, kinetic energy is a measurement of temperature. As an object, this is important. As an object temperatures increase, the object radiates more strongly at shorter wavelengths. Oh, and then it's going to go through and show you Vane's law, all right? In how different colors register different temperatures. And again, I cover it more so in the notes, okay? I'm not going to require you to know Vane's law and do any calculations. If you would like to do some of that stuff, just let me know. And it also talks about, again, I go over it more in the notes, black body radiation and the different colors and temperatures of black body radiation. So that's about it. Again, for more help, watch those notes.